Hi, good day. My name is Gava from Bachelor of Science in Computer Science 2A. I am from the Group 2 and my members is Johnben, Augustus, Nadal, and Roberto Bayos Jr. So for today's discussion, I will discuss about the limitation of power, the approximation algorithm, and the randomized algorithm. So the activity is all about the discussing the two algorithms, the approximation and the randomized algorithm, and discuss in class or for an example for a real life problem for the two algorithm and provide proposed solution for the given problem. So first, let me define what is the approximation algorithm. So in computer science, an approximation algorithm is a particular kind of algorithm to address the optimization issues, finding a solution to a problem that is close to the optimal answer. Although not always the optimal solution is the aim of an approximation method when it's difficult or impractical to find the precise optimal solution of a problem. So the real life problem that we provide in this approximation algorithm is the field of computational geometry, and it uses the Douglas-Poker algorithm. The Douglas-Poker algorithm is used to simplify a curve or a polyline by removing unnecessary points. It works by iteratively selecting the point on the curve that is farthest from the line segment, connecting the start and end point of the curve, and then removing it. The process is repeated until the maximum distance between the curve and the simplified version is below certain threshold. So the Douglas-Poker algorithm reduces a curve's complexity by omitting some points, making it approximation algorithm. This indicates that while the simplified form of the curve is close to the original curve, it is not exact match. The threshold value that is used to choose which point to keep and which discard affects how accurate the approximation is. A closer approximation will be produced with a lower threshold number, but the resulting curve will have more points and more complicated. Although the approximation will be less precise with higher threshold number, the curve will simpler and contain fewer points as a result. So this is the proposed solution for the approximation algorithm. So this is the code that the group 2 made. So first we have the base case. If there are two or fewer points, return the points as is. And find the point with the maximum distance from the line segment. Next, if the maximum distance is greater than the threshold, recursively simplify the two halves of the curve and simplify the left and right halves. Next, concentrate the simplified curve using the return and result method and if else method. So next we did is the calculate the distance between the point of the line and define by the start and end points. And next to print the simplify or the example usage, ito yung points, the example usage, and we simplified it in print. So pag meron natin yung program, the result will be 1, 2, 3, 3, and 5, 1. So that will be for the approximation algorithm. Next that I will discuss is about the randomized algorithm. So in algorithm that makes significant use of randomized of its functioning is called a randomized algorithm. To solve problems randomized, algorithm used to random decision or choices while they are being executed. Algorithms can be make advantage of randomness in a variety ways. For instance, the randomized algorithm may employ random integers to decide which step to perform next, which data to process first, or which nodes in a graph to visit first. So the real life problem that we made for the randomized algorithm is the min cut problem for finding the minimum cut in the graph. So a cut in a graph is a partition of graph's vertices into two disjoint sets. The weights of a cut is the sum of weights of the edges that connects the two sets. The minimum cuts of a graph is the cut with the smallest weights. So the minimum cut algorithm is randomized algorithm that can be used to find the minimum cut of a graph. It works by repeatedly selecting the random edge in the graph and contracting it. The process is repeated until there are only vertices left in the graph, at which point the minimum cut is the set of edges that are contracted. So this is the proposed solution and the sample code that we made for the randomized algorithm. Next, the first thing we did is make a copy for the graph for the min cut problem and use the while loop method and select a random edge. Next, merge the two endpoints into a single vertex and return the edges of the minimum cut. So next example of usage. So we use the import networks as nx and graph as nx.graph. Graph. So next, print the min cut and print 1, 2 or the weight 1 or 1, 3 for the weight 2, 1. So pag nara natin yung program, the result will be the 1, 3, weight 2, and yes, yun yung result. So it will be for our discussion for the limitation of power. Thank you for listening.